So the Earth, as you know, is a sphere, and the position on the globe, to give the position on the globe, is divided up into a grid system. So your grid system goes from the equator in the middle, 0, up to north, 90 degrees, down to the south, 90 degrees. So it measures north, south, from the equator, 0 to 90, which is your latitude. So the UK here is between 50 and 60 degrees north of the equator. Longitude is measured from the Greenwich meridian, or the prime meridian, and it runs through Greenwich, and it's measured east and west 180 degrees. So here we can see that the Greenwich meridian actually runs through the Royal Observatory in Greenwich in London, and it meets at the back of the planet at the 180 degrees on the dateline. So the position is given by latitude and longitude. Latitude is measured 0 to 90 degrees north or south of the equator, which we've said, and the longitude is measured 0 to 180 degrees east or west of Greenwich. So now we have a grid system. We can work out our position anywhere in the world, north or south of the equator, on east and west of Greenwich. So if we look at the position here of New Orleans, which is 30 degrees north and 90 degrees west, we can go 30 degrees north of the equator on the line there, and then we'll go 90 degrees west from the Greenwich meridian, and where these two meet will be the position of New Orleans. Plotting your position. How to plot your position on the chart from a GPS position. You will need your dividers. So with your course you should have your one-handed dividers. You squeeze in the top to make it bigger, squeeze in the bottom to make it smaller. If you've got the RYA dividers for the ENS course, you'll just twist in the middle and it will open it and it will close it. You will have a plotter. This is a Breton plotter. An oblong piece of plastic with a big arrow at one end and a rotational disc in the middle with the between 0 and 360 degrees and small arrows in the middle, and we'll talk about this in a minute. So we need to plot a position by latitude and longitude. We'll get our latitude and longitude from our GPS set, and we want to plot that on a chart to see where we are. If we look at RYA chart 3, if you get it out, lay it out and it's full on the table, you'll see in the middle here it says 46 degrees north. That's 46 degrees north of the equator. And at the top here it says 6 degrees west. That's 6 degrees west from the prime meridian or Greenwich meridian. So the question we want is, what chart symbol is at the position 46 degrees 23.35 north and 006 degrees 23.4 minutes west. So we know it's north of 46 degrees and west of 6 degrees. So if we look at our chart, we know it's north of the 46 degrees and we know it's west of the 6 degrees. So we know it's going to be in this part of the chart. So what I suggest you do is fold the chart 3 in half and have a look at the top left hand corner. And when we look at it, we'll see that the scale on the side, the latitude scale, will be 46 degrees, 10, 20 and so on, 6 degrees, 10, 20 and so on. So if we look at the top left hand corner, here we go, top left hand corner, we can see the chart. We know that everything above here is 46 degrees. So we look at 46 degrees, 23, so we count out from here. So it'll be 20, 21, 22, 23 here, decimal 35. And here it is, 23.2, 0.3, and halfway again, 0.35. Now what I want you to do now is just put a small pencil mark on here. And from your small pencil mark, get your plotter and put your plotter 90 degrees to the side of the chart and draw a line here that's 90 degrees from your small pencil mark. The tip is to stand up and look straight down at the plotter. Spend a bit of time and effort here to make sure that your plotter is 90 degrees. So this line here is 90 degrees the side of the chart. You want to get into the habit of doing this properly, because a lot of mistakes later on is because this line tends to end up wibbly wobbly because we're not careful. We go to the top of the chart, 6 degrees we said was over here, counted across 6 degrees, 22, 23, 0.2, 0.4. Mark off on here, draw a line straight down. And where they meet will be our position. So the position of 46 degrees, 23.35 north and 006 degrees, 23.4 west is the drilling platform Alpha Juliet Delta on the top left hand corner of your chart. There it is, plotting your position by latitude and longitude. We can also plot our position by distance and bearing. So if we're given a distance and a bearing, we can work out our position. And the question now is, what feature is 7.4 miles at a bearing of 232 degrees from Point Victoria Light? So first of all, we need to find out where Point Victoria Light is. And here it is on the chart. The position of a light on a lighthouse is in the dot in the middle of the star. So here's Point Victoria Light, dot, star. We know it's a light because it's got a little purple or magenta teardrop to it, but the position is right in the middle of the star there. 232. So I'll always say this, we need to take a step back, look at the big view, then go forward and look at the detail. Where is 232? Sometimes it's helpful to draw a compass rose like this. So we've got north, east, south, west. 232 is over here. So we know 232 is going to be somewhere in this direction. So our line at the end needs to be in this direction. This may sound oversimple to you, but it's really easy to put the plotter upside down, put the arrows in the wrong direction, and we can quite happily zoom off in this direction. And I have seen that happen in a Yacht Master exam. So think of the big picture in your head first, and then when you finish, does that match up with the big picture? If it doesn't, you've probably got the plotter upside down or the arrows in the wrong direction. There we go. Pointing in this direction, what we do first of all is lift up the plotter, have a look at it, put 232 here in this circle, put it on the chart, put the edge of the chart on the lighthouse, and big arrow goes in the direction of 232, little arrow goes to the top of the chart. So put it on, slide your plotter up and down, twist it round until these arrows here match up with either the vertical line on the chart or a horizontal line on the chart. You may need to move it around a little bit. It's sometimes easier to get this middle disc over where the sea is so you can see where the arrows are, and then stand up, look straight down. Make sure your pencil is on the center of the lighthouse, and then draw the line down here. Okay, so we have the disc lining up with the vertical line or the horizontal line, little arrows going to the top of the chart to north, big arrow in the direction you're going. Then we need to measure 7.4 miles. We always measure from the side of the chart. So measuring 7.5 miles at the edge, count 7 and then 0.4 at the end. And then take it with your plotter to the lighthouse, measure 7.4, and that'll be our position. You can either leave the plotter on there or you can draw the line and measure from the line. Distance. Well, this is just the opposite way round of what we've just done. So we need to work out an angle between 2 points and how far it is. It's easiest explained in an example. So we're going to measure the distance and bearing from Point Victoria Light to the oil rig that we've just looked at. So here we go on the chart, easier to see. Point Victoria Light, It's in the middle of the star, and the oil rig, the position of it is the dot in the middle. So we need to measure the distance and the angle between the two. So it's from the light towards the oil rig. So we'll get our plotter. We lay the edge of the plotter on the lighthouse at Point Victoria Light and on the oil rig. And make sure that it is lined up carefully and correctly. It's easier to stand up and look straight down. It's good to have a sharp pencil, a 2B pencil if you can get hold of it, and draw a line between them and make sure the pencil line goes through the middle of the lighthouse and the middle of the buoy. It's good to get in good practice here, because once we set off with good practice, we'll keep this good practice all the way through our navigation. Make sure the big arrow on the plotter here is pointing in the direction you're going. It says here, direction of bearing, and it tells you on the plotter. And then rotate the middle of the plotter so the small arrows are pointing towards the top. And then align the grid in the middle of your plotter here on the rotating disc so it lines up with the vertical or horizontal lines of the chart. I find it easiest to stand up, look down, and then move the plotter so it's over the sea, so it's easier to see these vertical and horizontal lines, and then make sure you double check that your plotter is between the lighthouse and the buoy, because it does tend to drift. Some people find it easier to put your pencil on the lighthouse and rotate the plotter round, but whatever you do, you want the big arrow in the direction you're going, little arrow pointing towards the top, and these lines accurately lined up with the vertical or horizontal line. When you've done that, when you look at the dial here, it will give you the bearing between the two. So we'll look at the dial, lift it up, look at it in the light, and it will tell you here that it's 232. Now that's 232 degrees true, because everything on the chart is measured in true. To learn about the compass and how we write on the chart, if you go to our compass tutorial, we'll explain that to you. Is this direction logical? So in your mind, draw a picture of a compass. North, east 90, south 180, west 270. Where's 232? 232 is about here. So in your mind, draw a line from the middle out and in this direction. Does this line up with what we've just been doing? Yes, it does. There again, yes, it does line up. We do this to make sure that we haven't put the little arrows at the bottom or the big arrow in the wrong direction, and we're not scooting off in 180 degrees in the wrong direction. So as I said before, look at the big picture, then look at the details. To measure the distance, we use our dividers. So with these dividers, you squeeze the top, make them bigger, squeeze the bottom, make them smaller. Put one end on the lighthouse, one end on the buoy. This is pictorial. You might find it better, and it is better practice, to have your dividers about 20 degrees to the chart, and the reason for that is it doesn't make holes in the chart and it doesn't make holes in the table you're using for your practice navigation. So measure these across, and we measure from the side of the chart. I'll come back to this picture. When we look at the side of the chart, we see that it's divided up. So this is 46 degrees north, 10 minutes, 11, 12, 13, 14, 15. So between here and here is 5 miles. Each one of these is 1 nautical mile. On your RYA chart 3, it's divided up into 1, 2, 3, 4, 5. So each one of these increments is 0.2. So 1 minute of latitude. So each degree, north or south on your latitude, is divided up into 60. One of those 60th is called a minute, and one of those is a nautical mile. So if we travel north or south 60 miles, we've travelled a degree. And then put your dividers on the side of the chart and measure the distance. So here it's on 20, and you count 1, 2, 3, 4, 5, 6, 7, 0.2, 0.4, and it gives us 7.4 miles. So that is bearing and distance. We steer our boat using a compass. So we look at the compass and we steer to the desired course that we're told to by the navigator. The compass on our boat points to magnetic north. The chart we work from points to true north. So if we have a look at the world here, you'll see all the lines of longitude point to the North Pole. When that's laid out on a chart, in a big scale, it looks like that, with your vertical lines going to the North Pole and the South Pole. So when we lay our smaller chart out, our RYA chart 3, we'll see that all the lines are parallel and they all point up to the true North Pole. The compass, as we said before, points to magnetic north. That's because the world is like a huge magnet, and that magnetic core is pointing to the North Pole and the South Pole, and it slightly moves each year. So the compass points to magnetic north. The difference between true north and magnetic north is called variation. So we call variation the difference between true and magnetic north. So on the left we've got the compass, which points to magnetic north. On the right we've got the chart, which points to true north. Depending on where we are, we're either going to get easterly variation or westerly variation. And we can find that out by looking on the chart. So to find magnetic north on your chart, all you do is go to your nearest compass rose and it tells you in the middle the difference between true north and magnetic north. If you look around the chart, you will see that they're slightly different. So that's because as we move around, we're changing our position in relation to the magnetic north and the true north. And that's represented on your RYA chart 3 with the difference between magnetic north and true north, which is the variation, is slightly different between the compass roses. So if we look at the compass roses, it tells us in the middle what the variation is for that year. In Day Skipper, we'll then calculate to what it is now. For all your essential navigation and seamanship course, they'll tell you what the variation is. We then take our variation and we put it in the middle of our plotter here, where it says total error, east or west. So if it says the variation is 7 degrees, we get a pencil and we mark 1, 2, 3, 4, 5, 6, 7. Mark it off here. So if it asks you to take a bearing and it gives you 7 degrees west, which it does in the question paper, you take the top of your disc here where it says north, or whichever your bearing is that you're looking at. You don't take it to the 0 here, you take it to the 7. So once you've marked your plotter, the plotter does all the work for you. So I'll say that again. If, as in section 3 navigation, it asks for 7 degrees west variation, you mark west 5, 6, 7 on here, and you take your plot from here. If you're doing the online course, there's a very good description of this in the RYA software program. If not, we'll explain it in the classroom. So get doing the exercises, have fun, I'll talk to you later.